Swayam Prabha. Digital India. Educated India.
Hello everyone and welcome to our session 28 on quality control and improvement with MINITAB. I am Professor Indrajit Mukherjee from Shailesh Mehta School of Management, IIT Bombay. So, we are discussing about the primary aspects of design of experiments, which is the stepping stone of improvement. Okay. So, whenever this process is in statistical control, then we can adopt this statistical experimentation to further reduce the variability and bring the mean to the target values, mean of the process to the target values, like that. Okay. So, in our discussion what we have mentioned in last session is that there are some controllable variables which are of primary focus for us, and I want to determine the setting of these controllable factors in presence of this noise variable or uncontrollable variables over here, and the inputs will always change because sample to sample variation is always there. That will contribute some part of error components when we are developing functions between x1 to xp with y characteristics which is the CTQ. So, I am more interested in developing relationship between factors and CTQ. So, it can be used for screening purpose before I go for full fledged experimentation, okay, or it can be during full fledged experimentation I want to develop the response surface or functional relationship that exists between y and x, like that. So, either for screening we use this experimentation screening to screen the variables, and otherwise what we do is that we try to develop the full fledged function and then try to optimize the function, like that. So, we are more interested in controllable factors, and at present our discussion will be confined with controllable factors and experimentation for that, and how to control that one so that I get the best CTQ conditions, like that, that is output should be optimized, like that. Okay. So, what we have to understand is that how do we experiment, with this control factor, how do we experiment. There are different ways we can do experimentation, like here you can see some control factors over here, speed, feed, controllable factors and depth of cut. These are the three factors we can think of, x1, x2 and x3, like that, and this is the CTQ which we are monitoring out of the, which is coming out of the process, and we are interested into these CTQs, like that. Okay. So, experimentation primarily can be done like trial and error methods that or maybe arbitrarily we can change any of the characteristics x1 factor over here, and keeping other things fixed, and we want to see what is happening on the surface finish. Then if we reach an optimal condition on speed, then I fix that one and then go to feed, like that, and then fix the what should be the value of feed that will maximize my surface finish, like that, and finally we keep speed and feed to the optimal level and then go for the depth of cut, like that. So, what we are doing is that we are linearly moving from one dimension to the other dimension and then to the next dimension, like that. This type of experimentation when we are doing, this is known as one factor at a time experimentation, and this is the trend you will see that most of the time if you are not knowing design of experiments, what you will do is that you will try to do experimentation based on with the controllable factors. What we do is that keeping other fixed, change one, then fix that one and change the other one, then fix that one and change the third one, like that. So, this way we try to go for experimentation if we are not going for statistical experimentation. So, this is known as one factor at a time. How many factors are there? You can see this is one factor, this is the second factor and this is the third factor over here. Okay. So, what we started with this is the first combination we have started 55, 85 and 80, 30 over here, and this is the y observations that we are getting yij. So, this is coming out to be 23 over here. Okay. So, I want to improve and means let us say we want to maximize the surface finish over here, which is coded variable over here and shown with some units over here. Okay. So, then what I will do is that keeping this 85 feed and depth of cut fixed, I have just changed the label of speed over here. So, 55 to 60 over here. When I have changed this one, the other things remain fixed, that means other two variables are fixed at 85 and 30, like that. When I have done this with one factor, I have changed this one, what I observe is that this is coming out to be 29, which is improving, that is I have got an improved position over here. So, this is an improved position, and then what I will do is I have already only 2 labels. Let us say this is 55 and 60. I want to enumerate only 2 labels. I do not want to go more than 2 labels for experimentation. Okay. Either I can set at 55 or 60, that is the option that I am having, and then what I will do is that I will change the next factor and fix this at 60 over here. We have fixed now speed 60 over here because we have seen improvement at 60 as compared to 55. So, 60 is fixed over here. Then from 85 I will change it to 90, which is the other second label of the feed over here, that we have options like that, and the third variable is fixed over here, that is 30 retained over here. So, I am going like that. So, second variable is changed, and what we observe is that surface finish is deteriorating now. 23 is the surface finish like that. Okay. So, but previous condition was better like that. So, what we will do is that we will fix 60 and then go 85. So, we have reverted back from 90 to 85 over here, and then what I will do is that third variable I will try to change over here. So, 30 this is not experimented from 30 to another position, that is 35, or the another label that is given over here where I can change, that is 35. Okay. So, we have changed speed, we have changed feed, and we are now changing the depth of cut over here. So, when we are changing the depth of cut to 35, what we observe is 24, which is inferior to the values that we have got over here, which is the best value we are getting out of this. So, out of this 4 experimental trial, which is done as a one factor at a time experimentation, we have got the best position over here. That means speed should be 60, feed should be 85, and depth of cut should be 30 over here, and this is the 29 value of the surface finish that we have got over here. Okay. Now, there are 3 variables over here, and some combinations of the variable, 4 combinations of the variable are shown over here, but there are another remaining 4 variable combination which we have not shown. So, there are 3 factors and all factors are at 2 level. So, total possible combinations, permutation, all possible combination over here, this should be 2 to the power 3 over here. So, this should be 2 to the power 3, that is equals to 8. So, total number of all combination is actually 8, but when I have done one factor at a time and gone by linear positioning from one location to the other, we have stopped with 4 combinations like that. So, we have stopped over here, although the number of trials is less, but we could have done, if we have done another 4 trials, maybe some other combination of speed, feed, depth of cut should have given me some values which may be 32 or something like that, which will improve the surface finish like that. So, one factor at a time does not do all enumeration over here. So, that means some of the combination over here which could have given a higher value of surface finish, we have missed out on that. So, we have missed out on that. So, what is required is that all possible combination we should check like that, and that is what we do in design of experiments. What we do is that all possible combination, and that is known as factorial design. What we do is that all possible combinations at different levels for all the factors are enumerated, and based on that we define. So, we are not going linearly over here, we are covering a total surface area like that, we are covering a total surface like that, and that we can think of as design of experiments, right way of doing experimentation. So, I am exploring all region, not just specific regions by moving in lines like that, what we are seeing in one factor at a time experimentation. So, there are advantages when I go for experimentation which is statistically sound in that case, and then there are other advantages which we will discuss afterwards like that. What is the advantage of doing design of experiments over this one factor at a time experimentation, but here what we can see is that we are not exploring complete region, that is complete enumeration where we should have done so that we could have got something better on the surface finish side and better combination of speed, feed and depth of cut over here. So, this is one factor at a time experimentation, and if I go for all possible combination of this, that is 8 combination over there, basically I am doing design of experiments. So, that is what we are doing in design of experiments over here. Okay. So, there are different types of statistical experimentation that we will try to discuss over here in this course. And these are all used for, we can think of one I told is screening like that. Some of them are very popular in screening experimentation, and some of them are popular for optimization. That means we want to optimize the response surface, and for that we have something which is known as response surface design like that, multiple response optimization like that. There are procedures which is used over here, but preliminary over here what you see is that 2 factor experimentation. This is the first one that I have written over here, 2 factor. So, we are moving from 1 factor experimentation, that is one way ANOVA that we have seen, to a 2 factor experimentation. We will try to understand like that, and the complexity will increase as we go ahead with the design of experiments with more than 2 factors like that. Okay. So, this is 2 factor experimentation we will try to understand, and then general factorial design, that means if it is more than 2 factor, how do we experiment, how do we analyze like that. Then there is an important concept which is known as blocking in factorial design, that we will also cover, which is an important area, or sometimes we call it as local control in experimentation like that. Blocking is an important technique in design of experiments. So, these are the pillars of experimentation like that. In factorial design we will talk about this, and then there will be fractional factorial for screening experimentation. What I told, there will be screening experimentation, and that aspects we will try to cover, and so certain scenarios may appear when we do not want to do all experimentation, because there are n number of variables, and if we have at least 2 labels, so 2 to the power n combinations are required, and in f is very large, and if very large, and in that case what will happen is the number of trials will be increased, and it becomes infeasible to control that one. So, I need to reduce the number of factors over here, number of factors which is significant over here, which is actually contributing to the CTQ, and which is when we change that impacts the expected value or the variance of CTQs like that. So, we want to reduce the number of factors like that. In that case what we do is that we go for fractional factorial design, and finally, when we do full experimentation with the potential factors that is identified based on the screening experimentation, we go for full scale experimentation. We develop a response surface also, and we optimize from here. So, we optimize the response function over here, and then try to determine which is the global optimal solution. We want to find out the global optimal solution over here. Okay. And that we will just address at a certain time point in this course, and then there will be scenarios when we have multiple voids like that, which is I can have CTQs which is more than one like that, and they are interrelated with each other. They are interrelated with x1 to xp, how they are related, and if we can develop a function with interrelationship between y1, y2, y3 like that, we can also optimize that function like that. So, first initially we will discuss about single response like that, and then what we will do is that we will also discuss about multiple response, that means multiple outputs. Also, how do you optimize, okay, what are the theories that goes behind multiple response optimization, okay, and how do you implement that in MINITAB. So, everything is related with how we will use in MINITAB, that way we will go, and how to analyze that one, okay, with some theories and some examples on MINITAB we will try to demonstrate. So, we will try with 2 factor design first. We will start with 2 factor design first, which is the extension of analysis of variance, one way analysis of variance, when we told that of x1 to xp, one of the factor, let us say x1 is changed, and this has more than 2 labels. So, that is why we have used analysis of variance, and if it is 2 label, we are going for 2 sample t test like that, that is similar. Okay. So, only thing is that analysis of variance control the type 1 error like that. So, that is kept at a fixed level, let us say 0.05, which we have defined earlier also. Okay. So, we will go for 2 factor experimentation. So, and before we move into 2 factor experimentation, there is also another technique which is also popular during it becomes popular around 1980, and one of the concept that was given by this person who is known as Taguchi over here is known as robust design, which is known as robust experimentation, robust design we can think of, and this is the time point when we talk about robust design, robust experimental design like that. So, in this case the concept that he tries to emphasize over here is that simultaneous optimization of we can say mean to the target values like that, and also we want to reduce the variability towards 0 like that. So, I want to simultaneously get a setting process setting condition which will not only bring the mean to target and variability to near to 0, and also it will require minimum number of experiments, number of trials, and that should be less than when we are going for full fledged experimentation, that is 2 to the power n, let us say. I do not want to explore full fledged experimentation over here. I will take part of this experimentation, part of these trials over here, and then and the results we can see that, and this person has also proved that the results are very close given a certain assumptions is true. So, in that case what happens is that I do not have to do so many trials like full permutation, full combinations of the all combinations of the factors like that. We do not need that one. So, he emphasized on that, and he told that using a signal to noise ratio index, signal to noise ratio indices we can think of, what he suggests that using that index which takes care of mean and variance, both the things, we can get a setting which is very robust and which will bring the mean to target value, also reduce the variability like that. So, this a typical scenario came when this idea was implemented like that. This experiment was carried out. What was seen is that Sony US is measuring some characteristics over here, and Sony Japan, they are manufacturing TV sets like that, and in that case color density is one of the parameter which was of concern to them, and they are seeing that Sony Japan, they are producing color density target value is given over here. They are producing when they have taken samples, the graphical representation of the CTQs that is coming from Sony Japan is like this. A normal distribution curve what you see, but Sony US, they are producing within specification, that is, this is the USL you can think of, and this is the LSL you can think of, lower specification and upper specification limit that is defined by the customer, and in that case he is using the whole tolerance zone over here. So, that means whole tolerance I am using over here, and it is consuming the full tolerance over here. So, this is a mentality which is known as goalpost mentality in earlier days, that is because of monopoly what they are doing is that they are producing within the specification, but the variability of this distribution is much more than the variability of this distribution over here. So, people are more satisfied, that is the idea of satisfaction level of the or voice of the process is this one, which is having less variability as compared to the voice of the process which is delivered by Sony US like that. And how Sony Japan is delivering that one, that is based on some concepts, that is robust design like that, is concept is given as robust design like that. It is exploring the nonlinear region over here of variability for a, so x is at a given position, x is changed from this level to this level, and this is the y characteristics that is being monitored, and this is the variability that is coming out when I am controlling the x in this region. But if I change the, if I go further away from this x variable over here, and this is the region, let us say B region over here, I am exploring A region to B region, and then what we see is that the due to curvature over here, what is happening, the reflection that is coming over here is much less, and the variability of the y characteristics that we are generating over here is having less variability as compared to the variability that we are generating when we are fixing the x in A region like that. A region can be defined like this region to this region, and B region can be defined like this region and this region like that. So, that is the idea what was Taguchi was emphasizing, that there is a nonlinear region where if I can shift the x condition to that region, then what happens is that my variability in y also decreases, and it also brings to the target value. Here only we are showing that variability is changing like that, we can bring it to target values by other conditions like that, by using other options. So, first is reduction of variability is important, then bringing the mean to the target value, that is also important, and that is done by one single experimentation, and based on that only we will identify which factor influences the variability and which factor influences the mean, and based on that we will make the setting so that I produce characteristics which are very close to the target value and also with minimum variability like that. This is one of the concept which is controversial, which is also controversial because statistician has also contradicted the idea of signal to noise ratio that I have mentioned, and theoretically statistician has also challenged these techniques like that. Okay, but this techniques gives results, and that is being proved in many industrial scenarios, and this requires less number of trials also, and because of that assumptions that we will understand, try to understand what is the assumptions that in Taguchi's method we try to adopt. So, and most of the scenarios in design aspects, at least when we are manufacturing some products, mostly we have seen that assumption holds like that. Okay, so that's why industry started adopting this technique because of the less number of trials like that, and getting the mean to target, and also the variability is going down. So, this is known as robust design concept that is given by Taguchi, and we will cover it at the end phase of our design of experiment lectures like that. Okay. So, first what we want to emphasize is that how we are doing two factor experimentation, and that is based on statistical experimentation. How do we interpret the results like that, and what are the possibilities that is given in MINITAB that we want to explore over here. Okay, that is the overall objective that we want to emphasize. Okay. Now, we have identified the factors, we have also we have shown in the process view of the characteristics that we are trying to generate over here, that is the CTQ, and this is a process view. There will be certain inputs over here, or it can be influenced, or we can think of maybe covariates which is influencing the y characteristics over here, but we are not interested into this. We want to freeze these controllable variables, controllable factors or variables over here, which we are more interested what should be the level of x1, x2 up to xp variables, and there will be some uncontrollable factors or variables we can think of. So, these factors or variables we will use this as a substitute. Whenever we can talk about factors also, we can say that is a variable also, okay, and which will take different labels during experimentation. Intentionally I am doing the change, and we are seeing the outputs change in the CTQs, and then we are basically trying to see that the factors influences the mean value or standard deviation values, and based on that we will make the settings. We will make the settings of controllable factors. So, we are more interested to set the controllable factors in presence of this, and there will be some factor which we will not change, which is rarely changed in a process like that. There will be some factors which are fixed, we cannot do anything over here. We will try to fix those factors like that, so that minimally impacts the y, that is the assumptions that we are taking over here. So, some are held constant, some are held constant, factors held constant like that. There are uncontrollable factor. This is an important area also we are trying to explore in design of experiments. That means these are z factors what we have written over here. These are uncontrollable, or uneconomical to control, that is the scenario, and how to exploit this information like that we will try to see. So, this can be considered as when we are modeling, let us say response surface we are developing, and this x1 to xp we are modeling over here, and the errors that we are getting in the model, that the errors is contributed maybe by this, one of the components is this, and maybe this input conditions also, variability, sample to sample variation will also contribute to the error, and that we cannot, that is unexplained variability we can say. So, we want a efficient model, that if I can get an efficient model, and if the error is minimum over here, in that case we can adopt that functional relationship over here to optimize the process, basically to optimize the process, that can be adopted. So, we are more interested in controllable factor and variation in controllable factors. How do we change controllable factors, and based on that design of experimental results, how do we interpret the results, and how do we fix the labels of these controllable factors like that, okay, that we will try to understand. And we have in design of experiments three important thing that we should note over here. In experimentation, the primary importance is given to randomization of the experimental trials like that. Okay, so we will explain what is randomization like that, and you may be knowing about randomization, generating random numbers like that. So, that concept is used from certain distribution we can generate random numbers like that. So, we have to do the experimentation in a randomized pattern like that. So, there will be no as such visible pattern, but we will have experimentation which are completely random we will select, and how to do that we will just try to explain with an example. And the second part is randomization of the trial is important, then replications is also an important factor. That means, when I am doing the trial at a given combination of speed, depth of cut, and the other conditions that we have considered in this experimental speed, feed and depth of cut, let us say. So, in this case, for a given combination of these three factors over here, I can repeat the trial in this at a given level fixed that we have fixed like that. So, the labels that we have fixed over here is that 55, let us say this is the first trial over here, 55, 85 and 30, and this combination I rerun again with the different samples like that, that is known as replication, that is known as replications over here, and that is what is done in experimental trial, because more the number of replicates over here. So, n equals to 1 means no replicate, n equals to 2 means 2 replication over here at a given condition of speed, feed and depth of cut like that. So, at a given combination, if this combination will be run 2 times. So, first sample is run over here, second sample is run, and observation of the CTQ is measured over here, observation of CTQ is measured over here, or we can say as y11 over here and y12 is the second observation that is recorded for a given trial like that. So, replication, why it is important, because if we replicate we are more sure, we go by average values, that is the central limit theorem, and that is the underlying assumptions that we are making over here when we are doing replication. More replications we can do in an experimental trials, more accurate will be our results. That means, if we can increase the what we have done in control charts, as the subgroup size increases, the precision of the control chart also improves like that. Okay. So, but there is always a cost associated with this. Whenever I am selecting the samples, in that case what will happen is that we will have a constraint on the cost aspects of that, and we have to consider that cost aspects before we decide how many replicates we will do, like in experimental trials like that. More you replicate, more precise estimation you will get, and more accurate will be your results or interpretation. And if you cannot replicate, in that case how to interpret the results, that is we have to also see. We have to also see in this experimentation. So, there is possibility that there will be no replicates in certain scenario, there will be replicates in certain scenario when we are doing experimental trials like that. Okay. And the third important aspects, which is known as blocking or local control over here. So, sometimes what happens is that the factor is uncontrollable, but it is known and uncontrollable. So, that type of scenarios we have to deal with those kind of scenarios. That means certain variables which we are unable to control, but we want to see our main focus is controllable variables, whether it impacts the mean value of y or sigma of y like that, or that CTQ like that. But some other variables may be also influencing my results over here. So, in that case what we do is that we adopt certain means to deal with this types of nuisance variable or uncontrollable variables like that, okay, which I cannot control in real processes like that. So, so if noise factor is, if this noise or nuisance variable or uncontrollable, we can think of uncontrollable factors over here, is known and controllable for the sake of experimentation. What we do is that we adopt blocking principle in experimentation. We adopt a blocking principle in experimentation, and blocking, we will try to understand how we can block a particular factor like that, and estimates the value of variance due to blocking over here. So, that we will deal with that when we are doing how to consider blocking in experimentation and how to interpret the results like that. So, one important aspect is that the noise variable is known and it is also controllable for the sake of experimentation basically. So, in that case we may use blocking. Okay. So, some of the techniques that is used, classical techniques that is used is Latin square design for blocking like that. So, those are typical scenarios where blocking can be adopted like that, and we can see some examples of blocking in experimentation like that. Okay. Sometimes scenario may be that noise is known and uncontrollable. I already have some information of the noise, and but it is uncontrollable for the sake of experimentation. Here also we can control that one. So, there are alternatives to this, it can be controlled. So, in this case certain scenarios we can also adopt Taguchi's experimentation methods to deal with this. That means, whenever noise is there, but we have some knowledge on the noise like that. So, one is classical approach of blocking, one is Taguchi's method how to deal with the noise variables like that. So, Taguchi goes by saying that for the sake of experimentation I can control like that. So, how it is done in Taguchi's method also we will see. Okay. So, how to deal with noise variables, but both of the scenarios what we are assuming is that noise variables or this uncontrollable variable is known, and for the sake of experimentation we can control that one. So, there is classical approach of dealing with this, and Taguchi deals with it in a different way like that. Okay. But if the noise is unknown and uncontrollable like that, if it is unknown, I have no information like that. So, the influence of the noise can be minimized if we are doing randomization, which we have mentioned over here in the initial phase like that, randomization of the experimental trials. Why? Because every factor we cannot identify during experimentation in a process. Sometimes what happens is that brainstorming and everything is done, but some important factors we may have missed, that is also creating variation in the process, that is also creating, but we are not able to identify immediately on that. So, it is unknown, but it can influence. So, to minimize the effect of influence of such hidden variables, what we do is that we try to do randomization. So, it will uniformly distribute the influence of the variables throughout the experimental data like that. So, it will have minimum influence on that. So, that is why they says that we should randomize the trials, like that. So, three important aspects we should know that in an experimentation: one is randomization, one is replication, and one is known as local control. What is known as local control? So, wherever blocking is possible, block that one and see the effect of blocks, and based on that you make an interpretation. But if you do not do that, you may get a distorted results like that. Okay. But always try to randomize and always try to replicate. That means, replication will give you more precision, randomization will help you to minimize the effect of hidden variables or variables which are unidentified, which we have not identified like that. So, these three aspects are very important, and we should we should be careful while we are doing this. So, experimentation. So, then we will try to see experimentation, how experimentation is done. So, this is one of the example that we will discuss in our next session, a paint adhesive strength problem over here. Paint adhesive strength, there are two factors. Now, we are dealing with two factors, more than one factor over here, and how to make the results and interpretation, that we will try to see. There is one factor named primer type and one factor named application method, and these are two factors that are changed, and the adhesive force, adhesive strength over here, which is the CTQ, that is measured, the values are given over here. So, for a given application method, which can be of two types over here, dipping and spraying, and primer type, which is of three types over here, that is three different levels we can think of. So, and every combination of this is run, and we try to see adhesive strength, and we want to maximize the adhesive strength. So, what is the combination of A and B factor that will maximize the CTQ or adhesive strength, like that. We will start with this in our next session. Thank you for listening.